Good day everyone. Today my team and I are going to present about a very crucial safety feature used in ship construction. So we will be discussing about the watertight bulkhead. Let's begin by understanding what a watertight bulkhead is. So a watertight bulkhead is a vertical structural wall inside a ship that prevents water from spreading between compartments during flooding. These bulkheads extending from keel to the deck are critical for ship subdivision and survivability in compliances with SOLAS standards. So SOLAS is International Convention for the Safety of Life at Sea. So this convention is something that is developed under the International Maritime Organization. So the need for the effective watertight bulkheads gained urgency after disasters like the Titanic, and today they are integral to damage control in all type of ships.
Now I'll be presenting the type of watertight bulkheads. By orientation, there are two types of watertight bulkheads, that is transverse bulkhead and longitudinal bulkheads. Transverse bulkheads are positioned across the ship's width, most common for dividing compartments like cargo holds and machinery spaces, while longitudinal bulkheads run along the length of the ship, used mainly in tankers to reduce free surface effect and improve stability.
So, type of bulkheads, type of watertight bulkhead. Okay. So by functional purpose, collision bulkhead located at the forward end prevent flooding from bow damage must be a specific distance from the forward perpendicular. Meanwhile, aft peak bulkheads located at the aft end protects the stern compartment and propeller shaft tunnel. So here we can see aft perpendicular bulkhead and forward perpendicular bulkhead, right? So bulkhead, the fore-peak bulkhead and the after-peak bulkhead are watertight collision bulkhead. Okay, this was okay. And moving on to the next slide.
Types of watertight bulkhead. By structural form, flat bulkheads constructed from flat steel plates with added stiffness. Common in cargo ships for watertight separation but requires more material for reinforcement. Corrugated bulkheads uses wavy plating that provides built-in strength, often used in tankers, saves space and weight by eliminating the need for stiffness.
Watertight bulkheads serve several key functions and purposes. So the first one is it prevents progressive flooding, which is it limits water ingress to damaged compartments, preventing it from spreading throughout the ship. So the second function is the watertight bulkheads provides structural integrity. It adds stiffness to the hull and supports overall strength of the vessel structure. Then compartmentalization. So watertight bulkheads divides the ship into sections for cargo, machinery, and accommodations, which is crucial for functional space and organization.
Functions and purposes of watertight bulkheads. Regulatory compliance, e.g. SOLAS, mandatory for safety certification, contributes to vessel classification and design approval, enhances ship survivability, helps maintain buoyancy and stability even after collision or hull breach, improves damage control, enables crew to isolate affected sections and manage emergency scenarios effectively.
For now, we will be looking at the key features of watertight bulkhead, that is full height continuous structure is extends from the ship bottom keel to the main or upper deck to ensure total compartment separation. For watertight integrity, it is constructed with continuous welding, sealed down and tested for zero water leakage. And for incorporates watertight doors, it is specially designed doors for crew or machinery access, must be operable under pressure and of, often hydraulically operated. For stiffness and reinforcements, it is equipped with vertical and horizontal stiffness to resist hydrostatic pressure from float water. For material and thickness, it is typically made from marine-grade steel. Thickness depends on pressure zone. Lower compartments need thicker plating. And inspection and access manholes. It is the small manholes included for inspection and maintenance, sealed with bolted covers.
Let's look at the working principle of the watertight bulkhead. So first of all, hull damage occurs. After the hull is damaged, the external force such as collision or grounding causes breach in the ship's outer shell. As a result, water enters one compartment. The affected compartment begins to flood due to the hydrostatic pressure from the sea. At this stage, the watertight bulkhead prevents lateral spread. The vertical barrier, which is basically the watertight bulkhead, stops water from moving into the adjacent compartments. Meanwhile, the hydrostatic pressure acts on the bulkhead. The bulkhead is designed to withstand the increasing water pressure, especially at the lower depths. Then, the ship maintains stability and buoyancy. Because only one or limited compartments are flooded, the ship can still float safely and stay upright. Because of this, the load is transferred to the hull structure. The pressure on the bulkhead is distributed to the surrounding structural members such as floors, decks, and side shells. Finally, the watertight integrity is maintained. Through high quality welding and steels, no leakage occurs, ensuring the safety of remaining compartments.
Okay, so for this next slide, I will be showing the construction of watertight bulkhead. So, first of all, we'll start by planning and design stage. Location and number of bulkhead determined based on ship type, compartment relation, and SOLAS rules. So we have to follow all of these when planning and designing. Next, material selection. Constructed from marine grade steel, material thickness varies by pressure zone. So depending on the pressure zone, that's how we pick the material. Moving on, fabrication of bulkhead panels. Plates are cut, shaped, and reinforced with stiffener, vertical and horizontal. Next, positioning and welding. Bulkhead installing during hull assembly continuously welded to decks, side shell, and bottom structure. So these bulkheads installed by welding. Okay, then integration of watertight doors and manholes. Special openings added and reinforced fitted with sealing mechanism. We have to seal the watertight to make sure it's watertight. Reinforcement at key areas, corners, door frames, and connection points strengthened to prevent stress concentration. And then finally, testing and inspection. Hydrostatic tests or hose pressure tests are conducted to verify watertightness. Okay, moving on to the next slide.
Applications of watertight bulkhead in ships. Bulk carriers compartmentalize cargo holds to reduce flooding risks and maintain trim during partial loading. Tankers, oil, chemical, LNG, prevent liquid spillage between tanks, use longitudinal bulkheads to reduce free surface effect. Passenger ships such as cruise and ferries protect accommodation spaces and comply with strict subdivision standards. Loadable length rule.
Alright, so now we'll be seeing the application of watertight bulkheads in ship. So for naval ship, enhance combat survivability. Subdivide key areas like engine room, magazines, and control centers. So basically, what it means here is that we simply just divide the room so it doesn't affect the other. Like, let's say the engine room got flooded, you don't want to affect the room surrounding it because it's already been divided. Next, we have Roro vessel and vehicle ferries. Prevent vehicle deck flooding from spreading, especially vulnerable due to open deck layout. Then we have submarines. Compartmentalized pressure hulls improve internal isolation in emergency flooding scenarios. So, like in case of flooding, the room won't quickly become pressurized and squeeze itself. Okay, that's all.
Thanks for watching our video.